Hey guys, welcome to this lesson. This is part 3 of non-exact DE, focusing on case 3. Number 6, y times the quantity x squared y squared minus 1 dx plus x times the quantity x squared y squared plus 1 dy equals to 0. First, we have to distribute y and x. So this becomes x squared y cubed minus y dx plus x cubed y squared plus x dy equal to 0. Then we will check if this is exact or non-exact. Partial derivative of m with respect to y is 3x squared y squared minus 1. And partial derivative of n with respect to x is 3x squared y squared plus 1. Since they are not equal, so this is an example of non-exact DE. So first step, we have to determine what case of non-exact DE. To do that, we have to find the difference of the partial derivatives. Partial derivative of m with respect to y minus partial derivative of n with respect to x. Partial derivative of m with respect to y is 3x squared y squared minus 1 minus partial derivative of n with respect to x is 3x squared y squared plus 1. We copy 3x squared y squared minus 1 and we will distribute negative to this expression. Negative times 3x squared y squared is negative 3x squared y squared. Negative times 1 is negative 1. Add like terms, 3x squared y squared minus 3x squared y squared is 0. Negative 1 minus 1 is negative 2. Can we divide negative 2 by m or n? No, right? Because we cannot cancel out something if we divide negative 2 to m or n. So this is an example of case 3. Then we will follow this formula to get the values of m and n, and so that we will get the IF for case 3. M times n over y minus n times m over x equals partial derivative of n with respect to x minus partial derivative of m with respect to y. So what is our m? Our m is y times x squared y squared minus 1 times n all over y minus n is this one is x times x squared y squared plus 1 times m all over x equals partial derivative of n with respect to x is 3x squared y squared plus 1 minus partial derivative of m with respect to y is 3x squared y squared minus 1. Cancel out y and also x. Then we distribute x squared y squared times n is x squared y squared n. Negative 1 times n is negative n. Distribute negative to this expression. So negative times x squared times negative times x squared y squared times m is negative x squared y squared m. Negative times 1 times m is negative m. Copy 3x squared y squared plus 1 and distribute negative to this expression. So negative times 3x squared y squared is negative 3x squared y squared. Negative times negative 1 is positive 1. Then we add like terms. 3x squared y squared minus 3x squared y squared is 0. 1 plus 1 is 2. Copy x squared y squared n minus x squared y squared m minus m. Then we will get all the coefficient of x squared y squared. Coefficient of x squared y squared. For this term, the coefficient is n. And for negative x squared y squared m, the coefficient is negative m. Do we have x squared y squared on the right side? Do we have x squared y squared on the right side? No, right? So this is 0. Last are all constants. We have negative n and negative m and 2. We have two unknowns, two equations, so we will get the values of n and m. So from n minus m equal to 0, transpose negative m to the right side, so we have n equals m. So n and m are equal. So substitute negative n minus m, so m is now n. Negative n minus n is negative 2n equals 2. Divide both sides by negative 2. N is equal to negative 1. Since n and m are equal, so our m is also negative 1. And the IF for case 3 is x to the power of m, y to the power of n. So IF, integrating factor, is x to the power of negative 1, y to the negative 1. Next is to multiply the IF to the given DE. Our IF is x to the negative 1, y to the negative 1. And our DE is x squared y cubed minus y, x squared y cubed minus y, x squared y cubed minus y dx plus x cubed y squared plus x cubed y squared plus x dy equal to 0. Distribute x to the negative 1, y to the negative 1 times x squared y cubed is xy squared. X to the negative 1, y to the negative 1 times y. The result is x to the negative 1, then dx. If we multiply y to the negative 1 to y, the result is y to the 0. Y to the 0 is 1. 1 times x to the negative 1 is x to the negative 1. X to the negative 1, y to the negative 1 times x cubed y squared is x squared y. And if we multiply x to the negative 1, y to the negative 1 times x, the result is y to the negative 1. dy equal to 0. Because x to the negative 1 times x is x to the 0. X to the 0 is 1. 1 times y to the negative 1 is y to the negative 1. So let's check if this is now exact. Partial derivative of m with respect to y. The result is 2xy. This one is 0. Partial derivative of n with respect to x is 2xy. And this one is 0. So it is now exact. Then we can use the process of exact DE. So what is constant for this term? The constant is y squared, right? So y squared times the integral of x dx minus, to have a positive power, we will reciprocate the base. So this becomes 1 over x dx. X squared y squared, we have function x, so this is 0. And we will reciprocate the base, so it becomes 1 over y dy equal to 0. Copy y squared. Integral of x dx is x squared over 2. The integral of 1 over x dx is ln x. The integral of 1 over y dy is ln y. And we add ln c. We multiply both sides by 2 to eliminate the denominator 2. So the result is x squared y squared minus 2 ln x plus 2 ln y equals 2 ln c. Then we add like terms. So we have to transpose negative 2 ln x plus 2 ln y to the right side. So we get x squared y squared equals 2 ln c plus 2 ln x minus 2 ln y. We factor out 2. So we have 2 times ln c plus ln x minus ln y. And using the properties of logarithms, we get ln of cx over y. So the final answer is, the general solution is x squared y squared equals to ln of cx over y. Next example. 7. The quantity of 5xy squared minus 2y dx plus the quantity 3x squared y minus x dy equal to 0. Let's check if this is non-exact or exact DE. The partial derivative of m with respect to y is 10xy minus 2. And the partial derivative of n with respect to x is 6xy minus 1. They are not equal, so this is non-exact DE. First step is to determine the case of non-exact DE, so we have to find the difference of the partial derivatives. The partial derivative of m with respect to y is 10xy minus 2. Minus the partial derivative of n with respect to x is 6xy minus 1. We copy 10xy minus 2 and we distribute negative to this expression. So negative times 6xy is negative 6xy. Negative times negative 1 is positive 1. Then we add like terms. So 10xy minus 6xy is 4xy. Then negative 2 plus 1 is negative 1. Can we divide 4xy minus 1 to m or n? No, right? Because we cannot cancel out something if we divide 4xy minus 1 from m or n. So this is another example of case 3. And we will follow the formula m times n over y minus n times m over x equals partial derivative of n with respect to x minus partial derivative of m with respect to y. So what is our m? Our m is this one, 5xy squared minus 2y times n all over y, minus our n is this one, 3x squared y minus x times m all over x equals partial derivative of n with respect to x is 6xy minus 1 minus partial derivative of m with respect to y is 10xy minus 2. We factor out 1y from the numerator so that we can cancel out common factor y from both numerator and denominator. So this becomes 5xy minus 2 y times n all over y. And we also factor out 1x from the numerator so that we can cancel out the common factor x from both numerator and denominator. So 3x y minus 1 x times m over x. Copy 6xy minus 1. Distribute negative from this expression. So negative times 10xy is negative 10xy. Negative times negative 2 is positive 2. Cancel out y and also x. Then we distribute. 5xy times n is 5xy n. Negative 2 times n is negative 2n. Negative times 3xy times m is negative 3xym. Negative times negative 1 times m is positive m. Here, we add like terms. 6xy minus 10xy is negative 4xy. Negative 1 plus 2 is positive 1. Then, we will get all the coefficient of xy. From this term, the coefficient is 5n. And for negative 3xym, the coefficient is negative 3m. On the right side, the coefficient of xy is negative 4. And all constants. So we have negative 2 plus m, negative 2n plus m equals 1. We can automatically get the values of n and m using our calculator. So go to equation. So then choose a sub nx plus b ny equals cn. Two unknowns, two equations. So the coefficient of n is 5. Enter. For m is negative 3. And on the right side is negative 4. For equation 2, the coefficient of n is negative 2. And the coefficient of m is 1. On the right side is 1. So, n is equal to 1. The first coefficient that we input is n. So, the first result is n. So, n is equal to 1. Next is m is equal to 3. if for case 3 is if equals x to the power of m, y to the power of n. So, the integrating factor is x to the power of 3, y. Next step is to multiply the if to the given dE. So, if times dE. Our if is x cubed y times the given dE. 5xy squared minus 2y. 5xy squared minus 2y dx plus 3x squared y minus x. 3x squared y minus x dy equal to 0. X cubed y times 5xy squared is 5x to the power of 4 y cubed minus x cubed y times negative 2y is negative 2x cubed y squared dx plus distribute x cubed y. Distribute x cubed y to this expression. X cubed y times 3x squared y is 3x to the power of 5 y squared minus x cubed y times x is x to the power of 4 y dy equal to 0. Let's check if this is now exact. Partial derivative of m with respect to y is 15x to the power of 4 y squared minus 4x cubed y. Partial derivative of n with respect to x is 15x to the power of 4 y squared minus 4x cubed y. Are they equal? 15x to the power of 4xy squared minus 4x cubed y. Okay. It's now exact, so we can use the process of exact dE. From this term, the constant is 5y cubed, then times the integral of x to the power of 4 dx. And for this term, the constant is negative 2y squared times the integral of x cubed dx. For n, since it has function x, so this becomes 0. So, equal to 0. We copy 5y cubed, and the integral of x to the 4th dx is x to the power of 5 over 5 minus copy 2y squared, and the integral of x cubed dx is x to the power of 4 over 4 equal to c. 5 cancelled out, and 2 over 4 is equivalent to 2. Then, we multiply both sides by 2 to eliminate 2. So, 2 times y cubed x to the power of 5 is 2 x to the power of 5 y cubed. Then, 2 times x to the power of 4y squared over 2, cancel out 2. We get negative x to the power of 4 y squared equals c times 2 is c. Then we factor out. The common factor is x to the power of 4 y squared. When 2x to the power of 5 y cubed minus x to the power of 4 y squared is factored, the remaining expression is 2x y minus 1 equal to c. So this is our final answer for second example. So that ends our lesson.